Something happened in the first weeks of 2025 that the American technology industry was not prepared for. Not in the way that a competing product launch is something you are not prepared for, where you knew it was coming but underestimated the timeline. This was different. This was the kind of moment where the assumptions that an entire industry had been operating on for years turned out to be wrong in ways that nobody had fully modeled, and the implications landed all at once. A Chinese AI company that most Americans had never heard of released a model that matched and in several benchmarks outperformed the best systems that OpenAI, Google, and Anthropic had spent billions of dollars building. That alone would have been significant. What made it genuinely shocking was the second part. DeepSeek built it for a fraction of the cost, using chips that American export controls were specifically designed to keep out of Chinese hands. In a time frame that compressed what the American industry assumed would take years into months. And then they released the underlying technology publicly, for free, for anyone in the world to use and build on. The reaction in Silicon Valley was not competitive frustration. It was something closer to vertigo, because if DeepSeek could do what it just did, under the constraints it was operating under, then the foundational assumption that American AI dominance was secured by chip export controls and sheer capital advantage had just been tested in public and found to be considerably less solid than anyone had wanted to believe. DeepSeek was founded in 2023 by Liang Wenfeng, who built his reputation and fortune running a quantitative hedge fund called High Flyer Capital Management. This background matters more than it might initially seem. Quantitative finance runs on computational efficiency, on extracting maximum signal from available resources, on finding mathematical approaches that outperform brute force. It rewards elegant solutions and penalizes wastefulness in ways that pure technology research environments sometimes do not. Liang brought that philosophy to AI development at a moment when the prevailing wisdom in the American industry was essentially the opposite. The dominant approach had converged on scale as the primary driver of capability. Bigger models, more training data, more compute, more parameters. The assumption was that capability improvements came primarily from throwing more resources at the problem, and companies with the most resources would produce the best models. This was not an unreasonable conclusion given the evidence available through 2023. The GPT-4 generation of models had seemed to confirm it entirely. DeepSeek looked at that consensus and built something that challenged it at the architectural level. The result blindsided an industry that had stopped seriously entertaining the possibility that the scaling consensus could be wrong. The model that detonated across the AI industry in January 2025 was called DeepSeek R1, and it introduced technical approaches that significantly changed the efficiency calculus of large language model training and inference in ways the field had not anticipated. The most consequential was a refined implementation of mixture of experts architecture that dramatically reduced computational cost without proportionally reducing capability. A standard large language model activates its entire parameter set for every piece of text it processes. DeepSeek's architecture activates only the relevant subset of specialized components for any given input, meaning the model does the work it needs to do without spinning up capacity it does not need. The result is a system that performs at a level comparable to much larger, more expensive models while consuming significantly less compute per query. The training process incorporated reinforcement learning from verifiable outcomes in a way that allowed the model to develop strong reasoning capabilities without the massive supervised datasets that American competitors relied on. The model learned to reason by being rewarded for reaching correct conclusions through verifiable steps, a process that proved remarkably effective at developing the structured, multi-step problem-solving that separates genuinely capable AI systems from ones that are merely fluent with language. The cost figures accompanying the release were what truly stunned the industry. DeepSeek reported training costs that were a small fraction of what comparable American models had required. OpenAI had spent hundreds of millions training GPT-4. DeepSeek's figures suggested comparable results for something in the range of $5 to $6 million. Those numbers were immediately scrutinized and partially disputed. The full picture is more complex than the headline figures suggest, but even accounting for significant uncertainty, the efficiency differential was real, and it was large enough to matter enormously. Here is the dimension that made this politically explosive rather than just commercially significant. Since 2022, the United States has maintained an aggressive export control regime specifically designed to prevent China from accessing the most advanced semiconductor chips used for AI training. The restrictions target NVIDIA's highest capability GPUs, the H100 and its successors, which became the dominant hardware platform for frontier AI development globally. The policy logic was straightforward. Advanced AI requires advanced chips. If China cannot access advanced chips, its AI development will be constrained. American AI leadership would be structurally protected by hardware access that Chinese companies simply could not replicate. DeepSeek trained its models primarily on NVIDIA H800 chips, a version specifically modified to comply with export restrictions by reducing certain interconnect speeds regulators had identified as critical. The H800 is a meaningful step below the H100 in specific performance characteristics. The policy assumption was that this degradation would be significant enough to matter at the scale of frontier model training. What DeepSeek demonstrated was that with sufficiently clever architecture and training methodology, the gap between restricted and unrestricted chips is considerably smaller than export control policy had assumed. The efficiency innovations that reduce training compute requirements also reduced the degree to which hardware limitations constrained final model capability. The controls did not fail entirely. They added real friction and cost, but they did not prevent DeepSeek from building a frontier model. And that distinction matters enormously for a policy framework built entirely around the assumption that they would. The semiconductor market reacted immediately. NVIDIA lost nearly $600 billion in market capitalization in a single trading session following the DeepSeek release, the largest single-day loss in American stock market history. Investors were not just reacting to a competitive product. They were reacting to the possibility that DeepSeek's efficiency approach could reduce overall demand for the highest-end chips across the entire AI industry, compressing the market NVIDIA had been positioned to dominate for years. The capability demonstration alone would have been significant. What turned a significant moment into a genuinely historic one was the decision to release the model weights publicly under an open license. Anyone in the world could download DeepSeek R1, run it on their own hardware, modify it, build products on top of it, and deploy it without paying licensing fees or operating within the usage policies governing access to OpenAI or Anthropic's models. The strategic logic behind this decision rewards careful thought because it is not immediately obvious. DeepSeek is a Chinese company operating under Chinese regulatory jurisdiction. Releasing their most capable model as open source means American companies, American researchers, and American individuals can all use it freely. The technology transfers instantly and globally, beyond any possibility of control. Why would a Chinese company do that? The answer operates on several levels simultaneously. It positions DeepSeek and Chinese AI broadly as the open alternative to closed American systems, building global adoption that commercial products cannot easily compete with. It accelerates global use of an architecture that DeepSeek has deep expertise in, creating an ecosystem building on their technical foundation. It demonstrates confidence that the ability to keep innovating is a more durable advantage than secrecy about any particular model. And it makes American export controls look significantly less effective in an extremely public way, all without DeepSeek having to say a single word about any of that explicitly. The open source release spread with a speed that illustrated all of these dynamics at once. Within days, DeepSeek had been downloaded millions of times, integrated into developer workflows globally, and sparked a wave of research building directly on its architectural innovations. The genie was out of the bottle before anyone with an interest in containing it had time to organize a response. The benchmark performance accompanying the release provided the technical substance behind the market and political reaction. On reasoning benchmarks measuring an AI system's ability to work through complex multi-step problems in mathematics, science, and formal logic, DeepSeek R1 matched or exceeded OpenAI's O1 model, which had been OpenAI's most capable reasoning system at the time. On coding benchmarks, similar results. On mathematical problem-solving at competition level, DeepSeek performed comparably to systems that had taken American companies significantly longer to develop and significantly more capital to train. The areas where American models retained clear advantages were primarily in handling topics that Chinese censorship requirements caused DeepSeek to deflect. Questions about Tiananmen Square, Taiwan's political status, and criticism of Chinese leadership produce refusals or evasions that American models handle directly. This is a real limitation for users who need those capabilities, and it reflects the regulatory environment DeepSeek operates within. But for the vast majority of professional, technical, and commercial applications that constitute the actual market for AI, those limitations are largely irrelevant. A software engineer using AI to write and debug code does not need the model to have opinions about Chinese political history. A researcher analyzing data does not need it to discuss Taiwanese sovereignty. The capabilities that matter for most real-world applications were demonstrated to be competitive, and for specific task categories, superior to what American companies had produced at that point. The deeper significance of what DeepSeek demonstrated goes beyond the specific model and its benchmarks. It is about what the efficiency gains mean for the trajectory of AI development globally going forward. The American AI industry had organized itself around a capital-intensive model. Building frontier AI required billions of dollars in training compute, thousands of the most advanced chips available, and infrastructure investment that only the largest technology companies or heavily funded startups could contemplate. This created natural barriers to entry that favored incumbents and constrained competition at the frontier to a small number of well-capitalized players. DeepSeek's efficiency innovations compress those barriers substantially. If frontier AI capability can be achieved at a fraction of the previously assumed cost, the number of organizations worldwide capable of training competitive models increases dramatically. Universities, smaller companies, government research programs in countries that previously could not afford frontier AI development, and other Chinese AI labs working on similar approaches, all move meaningfully closer to the frontier. The moat that American companies built around frontier AI through capital advantage becomes significantly shallower. This dynamic is already visible in the response from American labs. Within months of DeepSeek's release, OpenAI, Google, and Anthropic had all announced efficiency improvements to their own models and training approaches, partially incorporating architectural insights that DeepSeek had demonstrated openly. American companies benefited from Chinese open-source AI research in ways that complicate any simple narrative of pure competition between sealed-off national efforts. The American response unfolded across several parallel tracks that collectively reveal how seriously the moment was taken at every level. Congressional hearings were scheduled. Export control reviews were initiated to examine whether existing restrictions needed redesigning in light of what DeepSeek had demonstrated about their limitations. American AI companies accelerated efficiency research programs. The Defense Department reviewed implications for AI applications in national security contexts. Both the Biden and Trump administrations treated the DeepSeek moment as a Sputnik-level event, invoking the 1957 Soviet satellite launch that shocked America into dramatically accelerating its space program. The comparison is instructive. Sputnik did not mean the Soviets had won the space race. It meant the comfortable assumption that American technological leadership was automatic and self-sustaining had been exposed as dangerously complacent. The response it triggered ultimately contributed to American space achievements the Soviets never matched. Whether the DeepSeek moment produces a similar catalytic response is genuinely uncertain. The structural differences between 1957 and 2025 are significant. American AI is predominantly private sector in a way NASA never was, making government-directed acceleration more complicated. The global interconnection of AI research means American and Chinese progress are not fully separable, as the immediate incorporation of DeepSeek's insights into American research demonstrated. And the efficiency innovations DeepSeek demonstrated are already spreading across the global research community in ways that make containing their effects essentially impossible, regardless of what policy decisions get made in Washington. DeepSeek R1 is not the end of this story. It is a data point in a trajectory. Chinese AI development did not stop with R1, and the efficiency innovations it demonstrated have become the new baseline from which the next generation of Chinese models is being built. The question is not whether Chinese AI will continue advancing, it is whether the gap between Chinese and American frontier capabilities, which the American industry had assumed was large and growing in their favor, turns out to be small and narrowing faster than anyone had planned for. The implications extend well beyond the technology industry. AI capability is increasingly foundational to economic productivity, scientific research, military systems, and the management of complex infrastructure. A world in which Chinese and American AI capabilities are roughly comparable, rather than one where American systems are definitively superior across every meaningful dimension, is a world with a different geopolitical structure than the one American strategic planning had been building around. The chip export controls being redesigned in light of DeepSeek face a fundamental problem. The efficiency gains that allowed DeepSeek to do more with restricted chips are algorithmic and architectural, rather than hardware-dependent. Tighter hardware restrictions slow Chinese AI development at the margins. They do not stop an industry that has demonstrated the ability to innovate around hardware constraints in exactly the way the export control architects had designed the policy to prevent. What happened in January 2025 was not China winning an AI race. Races have finish lines, and this one does not have one in sight. What happened was that the distance between the leading runners turned out to be dramatically smaller than the runner in front had believed, revealed at a moment when that runner had already spent years and billions of dollars operating on the assumption of a comfortable lead. That revelation changes the race, changes the pace, changes the strategy, and changes what winning even looks like from here. The technology that came out of a hedge fund manager's AI lab did not destroy ChatGPT. ChatGPT still exists, still serves hundreds of millions of users, and OpenAI remains one of the most consequential technology companies in the world. What DeepSeek destroyed was the comfortable assumption underneath all of it. The assumption that the outcome of this competition was already determined. That assumption is gone, and every serious person running in this race knows it.